Hi, I'm Nicolas Lassol from the University of Lorraine in France. This demonstration video presents a tool which has been created to assist RDF data editing. RDF is the core model of semantic web, which relies on the definition of triples of the form subject, predicate, object. A set of triples form a graph, which can be related to an ontology to bring knowledge about a specific domain. RDF data editing is often a manual task, and it can be really tedious for the concerned users. So the aim of this tool was to assist users in this editing task by implementing a suggestion system. Two different methods have been proposed. The first one is related to the exploitation of the ontology knowledge, in particular the knowledge about the properties which are used to describe resources. And the second method is related to the use of case-based reasoning. The idea was to take advantage of the already edited content which exists in the graph. With this method, the main challenge was to be able to find resources which are quite similar to the currently edited resource. The proposed system has first been developed for assisting the editing of an historical corpus, which is the Henri Poincaré correspondence corpus. So in this video you will find an example related to this corpus, related to the editing of a letter, which includes the definition of properties such as the sender, the recipient, the quoted people, the topic discussed in the letter, etc. While this system has been created and evaluated with this corpus, it is not specific to it, and the proposed methods could be applied to other corpora. Thank you for listening and enjoy the video. Bye. Hi, the tool presented in this video intends to assist users for the editing of RDF data. It combines the use of case-based reasoning with a deductive engine based on RDF's entailment. The first four tabs correspond to four versions of the suggestion system. The history tab lists the database updates, the user's action for the current session. And the three other tabs are used to get some information and statistics about the RDF graph and the ontology. Now let's consider the editing of a letter. We select its type and we give it a label. Once a resource is created, the database is updated and the context of the resource is refreshed. Refreshed corresponds to the set of already edited triples. So now we can continue the editing. The autocomplete mechanisms provide some suggestions, which are based on similar situations and on the domain knowledge defined within the ontology. At any moment, we can select a resource and print its detail, which will be shown on the right table. And this panel can be hidden at any moment. So we use the updated context of the letter to refine the ranking of the suggestions. So for the example, you have Henri Poincaré, which is suggested as the recipient of the letter. Now we are giving the place of archive, which is stored the physical document. So we can also update or delete triple. We just have to select the triple on the context table and perform the action. So this triple has been removed, so we need to specify another sender. And I'm going to stop here to explain this situation. In this example, you can find Eugénie Lenoir as the top suggestion for the sender of the currently edited letter. She was the mother of Henri Poincaré, and she's the most frequent correspondent in the corpus. And the system looks for similar resources and ranks the suggestion based on their frequencies. And that's why she's the top suggestion, because in this example, the context of the letter is quite limited. So we just look for all letters in the RDF graph, having Henri Poincaré as the recipient of the letter, and then we can see that Eugenio Leroy is the most frequent. But in other situations, it can be impossible to find resources with the exact same context, and in these situations, the system uses a flexible search mechanism, which is based on query transformation rules, in order to perform approximate search. So now we set Eugenio Leroy as the sender. We update the label of the given resource using the update action. And as the label is present in several fields, we update the different fields. The history related to current resource can be found at any moment. So we can see all the actions performed by users. And we can keep adding more reports for describing this process. Thank you for watching.